second function that we modified. So this one was the get is fortified function right here. Originally, this was a flag, so it would get unit at whatever this 2 position is, and then it would get is fortified, and this would return either a 1 or a 0. Um, so right here, I changed it from returning an int to a boolean, and then we can check here at whenever we initialize it, it is always false because whenever a unit is created, it's not fortified out of the box. So then we can go back to get is fortified, and we can see if it already is fortified, then this will be called, and it can go in an unfortify, which is right here. So it just sets is fortified to false, and the opposite. If you want to fortify something, then it will change it to true. So we can see in the tests here, we have this archer, and we're going to fortify the red archer, check that it's true, and then to check that it's defortified, first we just check that a created unit is not fortified. Then we check again after it's fortified to see that it's true. Then we're going to move the unit, which will unfortify that unit, and that will return false. So I'll go ahead and run these tests for you. And they're all 45 tests passed. So thanks.
Hi, my name is Caleb Foster. I am on Team 6, and I focused on refactoring the move unit function. So the big issue that regarding the code principles that move unit had was doing one thing. So this is the older version of the code. So right now, move unit checks to see if it's a mountain tile. And it will return false if it's a mountain because you can't move over the mountain. And then it goes into this distance calculation. So it makes some doubles from the from and to position, and then does this distance check to see if it's more than 1 tile away. And then after doing that, it runs into these try catch statements where it does a bunch of checks to see if unit attacking or city attacking or fortification is necessary to change because at this point all of the moves are valid, so it checks to see what kind of move is needed in that case. So right now it's a little bit hard to read because of the fact that it's responsible for doing so many things and calling so many different functions. In order to refactor it to make it a bit more readable, this stuff can be broken down into its own functions such that using descriptive names that the functions become more readable, and somebody who's not necessarily as familiar with the code base can look at move unit, understand what it's doing, and then if need be can go and look into those other functions to see how they're operating. Okay, so now looking at the refactored version of the code, so move unit now does the tile check and then still returns false if the tile's a mountain, and then it calls a function called distance check and returns a distance valid, and then does one conditional case where based on the value of valid distance, it returns the value from this function valid move unit, and both of these helper functions take in the 2 position variables that are passed into move unit. So off the bat, just looking at this, it is much simpler to understand what's going on. This function is obviously checking a distance. This variable is storing the validity of that distance, and then this function is returning a valid unit move. Scrolling down into those helper functions, so all of this code was just copied over from the old version of move, so it's still getting the rows and columns in both positions and then calculating the distance and then returning false or true if that tile that is put in is 1 tile away. And then similarly, valid unit move is doing the same thing where If the player is the player in turn, it goes through these try catch statements, seeing if unit attacking or city attacking is necessary. Um, Regardless of if attacking is needed, it will move the unit to an empty tile, and then it checks to see that fortification. So going down to the unit move empty function here, so it takes the attacker and then changes it to the next position, and then it sets the location in our unit grid. But based on the refactoring principles, it is now much more readable to understand what move unit is doing via these helper functions and the descriptive names, and it keeps the amount of logical steps that the function is actually doing much less. So again, somebody not as familiar with the code base can understand what kind of stuff is going on at a glimpse, and then go and able to dive into the helper functions to understand what's kind of going on under the hood.